Hey everyone, welcome to Code World, and today we'll be going over LeetCode Problem 125, Valid Palindrome. This is another problem from the Blind 75 list, which is a list of problems commonly asked in coding interviews. So in this problem, we are basically given a string, and what we want to know is whether or not this string is a palindrome. A palindrome is a word, a phrase, or a sentence which reads the same both frontways and backwards. So in this problem, we're given this string s, and we want to return true if it is a palindrome, or false if it is not. And what we're told in this problem is that we're given some specific conditions. We want to converse, when checking whether or not the string is a palindrome, we want to check after converting all uppercase letters to lowercase letters. And furthermore, we want to remove all non-alphanumeric characters from consideration. So given these conditions, we can look at a few examples. We have first the string race car. So we see that the race car string reads both the same front ways and back ways, because at the front we have an R and we have an R at the back. Subsequently, we have as the second character from the front an A, and the second character from the back an A. We also have as the third character from the front a C, and third character from the back a C. And finally, as the fourth character, both from front and back, we have an E. So this string reads the same both front ways and back ways, and so it is a palindrome. Next, we have the string race car with a space between race and car. Now, given at these conditions, we are told to skip non-alphanumeric characters. We do not need to consider the space. Therefore, just like race car without the space, this string is also a palindrome. Finally, we have an empty string, and we are told in LeetCode that empty strings should be considered valid palindromes. So for this example, these are all valid palindromes. So I've prepared two examples for you guys so that we can run our algorithm on this problem. I will be showing you guys the most efficient algorithm for this problem, and this algorithm has a linear time complexity and a constant space complexity. This algorithm involves using two pointers, and we will start off our pointers with one indicating first the first letter in the string, and the right pointer instead starting from the last letter in the string. So we have our left pointer at index 0 and our right pointer at the last index of our string. And in this first round, round 0, we will be comparing the characters at these positions. So we compare the R to the R, and we see that these are identical characters. So we can move on and move our left pointer one spot to the right to index 1, and we will move our right pointer one spot to the left. Now we compare the two A's in round 1, and we see that these are identical. And once again, we are fine with our algorithm, so we will move on. We shift our left pointer one spot, and we shift our right pointer one spot. In this next round, we compare the two C's. They're identical, so they're fine as well. Again, we shift our left pointer one spot to the right, and our right pointer one spot to the left. Now our right pointer has hit a non-alphanumerical character. We have a space here. In the LeetCode example, we are told that we can skip non-alphanumeric characters from consideration, so we will just go on and simply move our right pointer one more spot to the left. And so our right pointer is now at the same spot as the left pointer. We're comparing an E to an E, so again these are identical. And we will then move on our right pointer one spot to the left and our left pointer one spot to the right. However, at this point, our pointers have crossed. So we know that we have checked every character in our string, and we have, in fact, a palindrome. In our next example, we have race a car. So again, we're going to start with our left pointer and our right pointer. We compare the two R's and we see they're identical, so we can move our left pointer and our right pointer. We compare the two A's and again they're identical, so we move our left pointer and our right pointer. We compare the C's, and they're fine, so we move our left pointer and our right pointer. So our left pointer is at an E, our right pointer is at a space. So at this point, we can move our right pointer one spot again. And we have our left pointer at an E and a right pointer at an A. So we see that here we have hit a situation where our pointers indicate different characters, an E for the left pointer and an A for the right pointer. At this point, we could just stop our algorithm and return false because the string is not a palindrome. And we see that in both of these cases, we are only traversing the string once. So we have, in fact, a linear time complexity algorithm. And furthermore, we are not using any additional data structures. So we have a constant space algorithm. Okay, so this is the most efficient solution, and we're ready to go back to LeetCode and write it up. Okay, so we're back in LeetCode, ready to write up our solution. We said we will be approaching this problem using 2 pointers. So we have a left pointer which will start off at index 0, and we have a right pointer which will start off at the end of our string s. Then we will run a while loop which will run until the 2 pointers cross. And while the pointers point at characters which are not alphanumeric, what we want to do is keep moving the pointers until we do in fact find alphanumeric characters, because we are told to skip non-alphanumeric characters. So what I'm going to say here is while not alphanumeric, and I'm going to pass in the character, and while left is smaller than right, because we do not want to go out of bounds, I'm going to increment our left pointer. Now this alphanumeric function is a function we will have to define ourselves to make sure that the character is alphanumeric. And I will do that at the end. Same thing for our right pointer. We're going to say while not alphanumeric, S of R. And also while the right pointer remains in bounds, we are going to decrement our right pointer by 1. After having found alphanumeric characters, what we want to do is just simply convert the characters to lowercase and make sure that they are equal. .lower is a built-in Python method which allows us to convert the character to lowercase. Now, if the two characters are not equal at those positions, so the pointers are pointing to characters which are not the same, we know that the string reads different backwards from front ways, and so we can return false. Otherwise, we will continue on to our while loop. And if we reach the end of the while loop where the pointers cross, then we know we can return true. And of course, at the end of each round in our while loop, what we want to do is increment our left pointer and decrement our right pointer to prepare for the next round. Now what we will do is write up our alphanumeric function. So remember, we wrote here a function alphanumeric which will check to make sure that these strings, that this character that the pointer is indicating is in fact alphanumeric. So we can just go up here and define a function called alphanumeric, and what it's receiving is a char that we pass in. And we're going to first of all convert this char to lowercase. And then we're going to take advantage of ASCII values in order to determine whether or not the character is alphanumeric. So we're going to say that the character is alphanumeric if the character is greater than or equal to the value of A and smaller than or equal to the value of Z, or if the character is a number. So it will then be greater than or equal to the value of 0 and smaller than or equal to the value of 9. And then we can return is alphanumeric. So this is all of the code. Let's run to make sure it works and submit. Yep, so it works and it's pretty efficient. So thank you so much for watching this video. I hope you found it useful. If you liked it, please give it a thumbs up and subscribe to my channel. I'll see you on the next one.